Okay.
So you do have the CPD link with you.
Yeah. All right. Looks like we still have some people in here. Yeah.
Eagerly waiting. Great.
All right. We will.
Yeah.
We will get things going ASAP. Shyam, can you see my screen?
Yeah. Can.
Okay. Let's get moving. Hello, everyone, and welcome to Volume 2, Series 2 of our Meet the Engineer series of events. We've had one event this year already where we spoke to a couple of aerospace engineers, and we're hoping to have a few more of these in the future. My name is Dr. Toby Elushakin, and I'll be your host for this evening. This event is an opportunity for young students, degree holders, school leavers, essentially to understand more about engineering, both in terms of the work itself and the personal experiences of those who will be presenting. This is the second event of the year. Excuse me. So this is the second event of the year, and we're hoping to have more of these in the future. Before we go ahead, a few house rules before we move. This event is being recorded, as you might have heard in the beginning, so that those who are unable to attend this event live will be able to revisit it in the future and access it. We had a few technical difficulties beforehand, and apologies for the delay that those technical difficulties caused. We will try and do our best to make sure that we still finish in time. The link to the CPD certificates will be posted in the chat, and please use the question and answer function to prepare your questions for the speakers. The webinar should take between 45 minutes and an hour, and we will try to keep to time. Our speakers today are two young professionals, Shyam Kolavarambathu and Eeshaan Vermar. Shyam is a systems engineer who is chartered, by the way, I should say, working with the UK Atomic Energy Agency, and Eeshaan is a systems engineering graduate who has worked on projects with Transport for London as well as the Ministry of Defence. They'll both be speaking to us about their journey so far and their experiences as engineers. Shyam will go first, followed by a Q&A session, and then we'll have Eeshaan speak with us, followed by another Q&A session. Afterwards, we'll have a few important announcements and then quickly close the event. So please welcome to our stage to speak to us, someone who I should say has always been behind the scenes with me, helping out with this event, but now is in front of the camera. So welcome, Shyam.
Thank you. Thanks, Toby. That was indeed a real special welcome, I must say. Right, so let me actually start by sharing the screen. So yeah, as Toby mentioned, this is my very first time. Please do take my apologies if at all something is not right and it's not the way it should be. But yeah, looking at Toby's agenda, I think I should be rushing in order to finish my presentations. So as Toby mentioned, yes, this is the Volume 2 Series 2 of the Systems Engineer Talk. I'm Shyam. I'm a BTech Master's in Science in Automotive Engineering, a chartered engineer recently, and am a member of the IET. So I will be taking through of who I am, a career catalog of what I've gone through, photo gallery, what I do, and how can you get there. So who am I? I am actually from Kochi, Kerala, India. So I try to bring in a picture of from the world where you can actually see India and where Kochi is situated in Kerala. I have got a 7 years experience in various roles in automotive engineering sector, and I'm currently working as a systems engineer at the United Kingdom Atomic Energy Authority for the project known as ESS Active Cells Facility, and it's been actually built in Lund in Sweden. My career catalog. So, excuse me. As I was thinking of building this slide presentation, I was actually thinking how to actually give a sort of a ride on where I was and how I got to where I am at the moment. So I started my studies as an engineer on 2018. I graduated in 2012 as a bachelor in technology in mechanical engineering. How do I get the passion to learn engineering? Mechanical engineering, yes, I loved cars. I loved repairing. I loved stripping out things, fixing it together, and get a satisfaction out of it. And that's what led to me in actually taking, studying mechanical engineering and taking the career path of an engineer. As and when I graduated, I was hired as a graduate engineer at Renault. It was a proper hands-on after sales, so all grease and oil in my hands, and it was quite a learning experience for me in that field. I applied to do my master's in the UK, but my application was rejected. So I had to sort of fill in my route of career path with a service supervisor at Maruti Suzuki. Then my application was accepted, and I actually flew to UK to do my Master of Science in Automotive Engineering. It was a one-year course. So 2014, I graduated with a merit, fortunately, as a Master of Science. From there, I got hired as a product development engineer at Tata Technologies as part of Jaguar Land Rover. Yes, I didn't go through an apprentice program. I didn't go through a graduate intern program as many of our engineers would have within the UK. But me being coming from India, doing a master's here, it was quite a journey to actually get into this product development engineer role with Tata Technologies. The experience that I gained while I was a graduate engineer did actually help me in bringing up my knowledge to put out for the product development engineer role within Tata Technologies. I gained Six Sigma Yellow Belt for the project that I actually did within Tata Technologies and Jaguar Land Rover, which helped me in applying for more serious roles. Being a resident engineer, I got hired within Aptiv. Aptiv is a supplier company. So what they do is they develop modules for car seats. So within Jaguar Land Rover cars, take any of the Jaguar Land Rover cars. If you sit in a car and you can make it work, vibrate, give you massage, make it move. That product is built by us. I will say, was built by us within Aptiv. As many people, COVID actually hit me as well. There were some issues with the contract, and I accidentally, there was issues with actually losing my job. But I didn't sit idle. I kept learning. I kept making my knowledge, my skills developing as it should. I did a Prince 2 course to achieve something, on the project management side of things, learn how things should be done, because I did get pretty much a knowledge of a technical side of things and how it works in a work environment. I applied as a systems engineer at UKAEA within RACE. So RACE is an acronym for Remote Applications for Control Environment, which I will get to when I actually talk about my career. And yes, so I got into systems engineering, which was more of a good challenge, I must say, which is currently what I'm doing and what I will be explaining in the coming slides. What I also did while I was applying for the new role is I sort of applied as a member of an accredited institution, which is IET, which I am part of. And I started the application for a chartered engineer directly, because I had enough experience from all those years to actually apply for a chartered engineership. And after the interview, I think they were certain that yes, this guy is good enough for chartered engineership, and I was professionally registered by the Engineering Council of the UK through the membership of Institute of Engineering Technology. So that's sort of my career catalog, how I got to where I am at the moment. Through this journey, there has been quite a good communication that I have kept through around different people's. If I start from here, this was Discovery, Land Rover Discovery that I worked in while I was part of the Tata Technology family. This is an E-Pace, which I was gifted when I really performed well. No, I'm just kidding. I wasn't gifted any E-Pace, but that is another car that I did work alongside while I was part of Tata Technologies. This is my team in Jack Land Rover. As you can, he's my manager, my mentor, my guide, who's been with the moment I joined UKAEA. Unfortunately, he's not with us at the moment. Bless his soul. This was my team, my Indian team, my Tata Technologies team. Back in Tata Technologies, it was a wonderful team to work with. As I move up, this is where the team that I dealt with, and these were photos taken back in Macedonia, where they used to build the seat modules that I explained while I was part of resident engineering. This was my recent team. We are having a desert party after the success of one of our projects that we did have tested and implemented. This was one of my volunteering work that I did with IET, and I was part of the Precedent 10 event. Precedent 10 was a worldwide event, that was really successfully taken, granted by everyone. I was a host. I was even a judge for a few of the events, the competition. It was well widely enough taken, and I could be part of it. I'm really glad that I was part of it. This is in fact the ESS active cells that the current system engineering work that I am working on. This is where we are building the ESS. So within the chat functionality, if you could give a try, everyone, what means system engineering to you, or what is system engineering to you? It would be nice to know within the chat if you could just drop in. Yeah, just drop in. What is system engineering to you? What does it mean? Do you know anything about system engineering? Just a one word, a one liner, that'd be really appreciated. Okay, I hope I'm looking at in the right box. Okay, integration. Okay, William Hall has said it's integration. Yeah, that's a good word, actually. That's a good integration is part of system engineering. Absolutely. Any more from anyone? If not, I'll continue with the presentation. Coming together of different engineering fields. Absolutely. Synergy. Okay, that's a good word. Okay, great. Yeah, thanks everyone for joining in with the question that I asked. So more into system engineering. Before I move into system engineering, I think I need to talk to you about where I work, UKAEA. So UKAEA is United Kingdom Atomic Energy Authority, and the mission is to lead the delivery of sustainable fusion energy and maximize the scientific and economic benefits. But the actual project that I work on is not related to fusion, but it has a lot of deal to do with fusion and the maintenance of fusion as and when we move on to the future. So what I work on is active cell system. So this is the concrete building that we are actually building in the facility that I did show in the previous slide. As you could see, it's very simple. We have this ESS facility, which is a Europe installation. So what they do in the facility is a science facility. After the science experiments, there'll be a lot of radioactive waste. So these radioactive waste is compressed, is handled, is processed, and dropped into different small boxes in order to dispose in the Swedish waste house facilities. So that whole process is actually done by this building that we are building at the facility in Sweden. So this is pretty much the VR view, the virtual reality view of the system that we are building. And as I explained, it's not a fusion experiment, but it is the large available remote handle facility within the world, and no one is going to enter it for decades. It's just going to be done handled with robots, and that's where Braze come into play. So Braze, as I mentioned, is a company within UKAEA who deals with a lot of remote handling equipment. So we have large manipulator arms that actually help in compressing these components as we could see. Why system engineering? Yes, so there were people who mentioned, it's an integration. It's bringing together different systems together, different fields together, and that's why system engineering is key here. A complex system of this sort, which has 47 plus different types of equipments. It's not one or two, it's 47 different types of equipments where there is people from control system team, people from software team, people from mechanical, electrical, bringing them all together and developing and delivering such a big system can only be done with the system engineering activities. That's why system engineering comes into play. So as people have participated, it is an integration of different teams together. It is bringing the synergy together. It is to bring the fields together, and that's why system engineering is really important here. So what do we do in system engineering? As you know, system engineering, there's a lot of, it's a V diagram, as you could see. What is a V diagram? We sort of define what the concept of the system that we are developing is. We split into different types of requirements from the customer, and after splitting the different requirements into customer, what we do is we design the actual equipment. After designing the equipment, we need to test. Obviously, we need to test, and so what we do is we test against those requirements that was actually built in the first phase, and then what we do is we sort of validate to the system requirements that the customer has given. So the function that the customer has actually asked us to build is being validated as we move on to the V diagram, the traditional V diagram of system engineers. So that's a high level of what system engineering is and why system engineering is used in active cell facility that I work in at the moment. I think one of the phrases that I actually like to use is the difference between a design engineer and a system engineer. So system engineering defines what to design, but a design defines what to build. So that's the sort of definition that I think gives you a clear idea of what a system engineering does and what a design engineer does. There are a few good reads. C-Book Wiki, NASA Systems Engineering Handbook are good reads that you can go through. There are a few recommended videos that I recommend you to go through, from the MIT Fundamentals of System Engineering, the MATLAB Tech Talks, which is a really easy, understandable system engineering tech talk, which I would recommend to go through in your free time. Right, how can you get here? So to get here, I think you have to have a short-term, mid-term, and long-term goals. 6 months, 2 years, or 4 years. You become a member of an accredited institute. IET, I recommend IET, not just because I'm in IET, because you have a lot of opportunities within IET. Be a member of accredited institute, so that you get recognition as you move forward. When in doubt, ask for help. You choose a mentor. You are school leavers. You are just coming into an industry of real work. A world of where you can find real big challenges. Having a mentor and getting guided is something that I would really recommend. Get trained. Keep updating your knowledge and skills, as I've done while I was out of job. Keep updating your knowledge and skills, because the where you go in is a really tough competition. So you don't want to be lost in the tough competition. Challenge yourself, but take one step at a time. Don't just be overwhelmed by too many challenges, and then you just get lost in what you want to really achieve. Maintain contacts. As you could see in my pictures, I maintain contact, and hence why knowing more people would definitely benefit in your future. Do not give up. Do not settle with what you have. Try, aim for bigger, and you will get what you need. Keep the right attitude. Changing your attitude help at times. And yes, as my papa, my dad always quotes, believe in yourself. You are made to do great things. Right. So finally, with commitment, when it's time, it will happen to you. So time is everything. It will happen to you. Don't worry. And thank you so much. I know I rushed through a bit, but I think I was able to help at least one of you to get through and to be where I am. Thanks for listening to me.
Thank you so much. I genuinely appreciate, especially that last part with the tips at the end for people who are looking to get to, the point that you've gotten to, especially, and most impressively, the chartered engineering designation that you were able to get. Well done on that, and well done on your career so far.
Thank you so much.
So I'm just gonna ask a few questions and then move on to Eeshaan, and then afterwards we'll have a nice Q&A session for the both of you. So I think the first question was how you found it transitioning into the UK, the UK's educational and work system. You had already worked for engineering firms in India, so we're transitioning to working within the UK. How did you find it, especially given that we have quite a number of international students here? I'm one of them, to be honest. I previously worked in Nigeria and then came to the UK for my master's and PhD. I know that we have quite a number of those types of people here. So please, a quick answer if you can.
Absolutely. I mean, that's a really good question, actually, because many don't really see the value of coming into an overseas and then looking forward for a job. But how do I find it? It was really challenging. It was really tough, honestly, trust me, because there's a lot of competition. You're not the only one. There are people like you. There are people in the UK, who gets the upper priority, I must say. But as I've mentioned within the tips, you must aim for high. It's not just studies. You have to show yourself. You have to commit to what you want to achieve. Definitely having this short-term, long-term, and mid-term goals helps you in achieving where you want. So definitely challenging, but it is not impossible. It's definitely something if I can do it, I think anyone can do it. So that's my answer to it.
All right, thank you very much. Okay, so we'll just move straight to our next presenter, Eeshaan. Eeshaan, you can turn on your video now. Yeah, thank you so much, Eeshaan, for joining us. If you've got a presentation slide deck, you can share that with us.
Let me just get that up for you. I think it's that one. Yep, can you see my screen?
Yes, I can. All right, go right ahead, and afterwards we'll have the Q&A session.
Right, perfect. So I'm Eeshaan Vermar. I'm a graduate engineer at Thales UK. So I've only been doing systems engineering for a year and a half now. So I'm not as experienced as Shyam, but hopefully some of my insights may help someone out there. So just to give you how this presentation is going to go, just a brief introduction on what's a systems engineer, then my university life as a grad engineer, and then next steps, guide for applications, some tips. I've done a lot of applications, so I can definitely tell you some stuff about that. So what is a systems engineer? It's a very broad sort of engineering field, and the Uncozy website has a very wordy description. But for me, I prefer what Charlotte University in America has published. And I definitely agree with them when they say systems engineering is concerned with the big picture of a project. You often have a systems engineer who's part of every single department. So from the procurement to the hardware to the electrical engineers, and just overlooking what work they're doing. I like to think of systems engineers as glue that sort of binds the entire project together and make sure everyone's on track. So yeah, definitely systems engineers are vital for any project. And this is a sort of view that I have of systems engineering. So as Shyam mentioned, what the sort of overview of systems engineering is the diagram. So there's the concept of operations, looking at the requirements, sub-requirements, and implementation and verification. And this is sort of just the tip of the iceberg. And often with really large projects, most systems engineers will be concerned with just this bit over here. And I've worked on very small projects as well, where it's just me being the systems engineer, and I've had to look at the technical debt, the legal issues, future trends, and the ethical and social issues, which I'll get to with some of the projects I've been doing. But yeah, so large projects, it's usually this section over here, and smaller projects where you're the sole systems engineer, you're looking at all of this. And okay. So what's my journey? So I started university in 2017. I had done maths, physics, and chemistry at my A levels, and I did really well in those. So I got to my first choice university, which was Warwick. I studied maths and physics, so not your typical engineering background. And during this time, I had absolutely no idea what I wanted to do. Just to show how much I didn't know what I wanted to do, I did a internship at Warwick Medical School where I was modeling the cytoskeleton of a muscle cell. So you can see this image in the background over here. And these are actually tubes in 3D. And I was using Python to image these tubes and model how it would look from a sort of radial configuration to a straight one. And I spent my entire summer doing that. And I found that even though this was sort of biophysics, I wasn't actually that interested in it. And during my third year, I joined two engineering societies. So that was Warwick Hyperloop and Warwick Aerospace. I really enjoyed the work I was doing at Warwick Hyperloop. We had just started out as a society, so I was part of the powertrain team and the electrical engineering team. So I was just doing battery testing, making sure the batteries don't explode when they're inside the Hyperloop pods. And it was really great fun. I met some really good people. And that's sort of when I decided that I want to go more into the applied physics / engineering sort of sector. And yeah, that's just me and the team when we just started out. I think we came 13th or 14th in the Hyperloop competition that was run by Elon Musk. So that's pretty good considering that was our second year of actually doing it. But yeah, so I decided to pursue engineering. However, during my time at university, I had really bad long-term health problems that started in about 2017. And because of that, I kept on missing lectures because I had to go to hospital and my health deteriorated during this time. And because of that, I got a 2-2, which isn't great when you're applying to jobs and looking for academic placements either. And because of that, I was really worried that I wasn't going to find a job. I wasn't, going to have a career, and this is going to really stop me from doing anything. But it turns out, even though I got those results, it doesn't really matter as much. As long as you persevere with what you want to do, you can get somewhere. So I applied to 70 different places, and I heard back from two. One of them was a software engineering firm in London, and the other one was Thales UK. And I chose Thales UK since it's a really great grad scheme and it's doing some really interesting work within engineering. So just to give you a brief background behind Thales, it's technically a French aerospace company, but they do basically everything. They make Oscar-winning camera lenses. They make 4 out of 5 World Bank security. They make a lot of satellites. They also worked on the James Webb Space Telescope. I think they made the Razor for that, and as well as some of the imaging panels. They do a lot of work in quantum computing and quantum security, as well as a lot of the defense sides. What I'm going to mention later is also working with TfL and the rail sort of sector, but we actually sold that off a couple of months ago, so that's no longer a part of Thales. So the grad scheme I'm on right now, that consists of 4 6-month placements and 2 year-long placements. So it's actually a really long grad scheme. So typically an engineering grad scheme is only 2 years long, but this one's 4 years. And the current one is 4 year-long placements. So that's also very, very long. But the advantage of this is you get to see a lot of the company and you get to do 2 secondments if you're really lucky, which hopefully I will be able to do in the future. So the different projects I've been working on. The first project I've worked on is the detection of faults within train tracks. And essentially what that is using a machine learning algorithm called a growing neural gas. And that takes data from the actual train tracks and any anomalies, it can detect that and then highlight that. And that was during my first 6-month placement. So it was just 3 months of pure research. And then in the next 3 months, I wrote a white paper that was circulated within the company. And that was just describing my research with an online growing neural gas and how it can be applied. Yeah, so that was quite a brief one. It was really interesting, but not where I wanted to go into the future. Then my next sort of placement, which sort of pushed me towards systems engineering, was with MMCM. So that's the Maritime Mine Countermeasures. So what you can see here is the USV, and it's essentially a boat that can go across the sea autonomously and have a holding pattern. And if I could just zoom in. So what you can see over here is the TSAM, which is the towed sonar array. And this essentially drags a sonar behind it. And the sonar detects different mines that are within the sea. And I haven't shown the picture here, but there's another USV, which is exactly like this one. And it's carrying a slightly larger submersible vessel, which is created by Saab. And this has like a tiny arm on it, and it goes to the actual mine and it puts a charge in it and then it blows it up. So it's made for mine clearance. A lot of what it's being used for now is World War II mines, as they're actually quite a lot in the English channel. It's really concerning. When I first found out about it, it wasn't great. But yeah, so that was systems engineering. The first 3 months of that was just going through documentation, going through the electrical engineering plan, all the interface control documents, trying to learn everything about the system, working with every single team. And then the next 3 months, I was focusing on technical debt. So what technical debt is, really briefly, is what the system must have, what would we like to have on the system, and what we could have in the future, and what really isn't needed. And essentially, I was going in between all the different teams. So that's electrical or the towed sonar array team or the autonomous software team, and just making sure they're on track and making sure everything works properly and integrates properly with all the different parts. So that was a really good experience. I actually got to go on one of the USVs, and I wasn't able to drive it, but going on it was a really good opportunity. The next placement was the Thales Theseus bid. And what that was this autonomous vehicle called a Hippo. And there's also a drone, which I don't think is in this photo. And what it's used for is that a soldier would have an app on their device, and they would say they would want medical supplies or ammunition or something like that. And the autonomous vehicle would detect where they are and then bring whatever they want to them. And the my entire role with that was looking at the legality and all the ethical and social issues with that. So it was still systems engineering, but it was more of the hidden stuff that you don't really see. And that was entirely focused on that. Unfortunately, we didn't actually win the bid, which isn't great, but it was a really good opportunity. I got to see it in action, and I actually got to fly a drone, which was really fun. And yeah, so that was that one. Then there's Watchkeeper, which I actually can't talk about that much because it's still ongoing, and the software is UKAEA only, so I can't go too much into that. But what I can tell you about is I also helped, or I'm helping to write a paper on Watchkeeper and trying to create a digital twin on that. So what a digital twin is a virtual representation of the Watchkeeper drone. And Watchkeeper is a surveillance drone, so it will have a holding pattern around an area, and it will take a series of images. So what I'm doing at the moment is writing a paper on how we can use a digital twin to improve the entire system of Watchkeeper, as well as any other sort of military drone, and how that reduces fatigue on an operator or information overload on whoever's actually looking at all the data. So that's sort of a side project of what I'm doing right now. My main project at the moment is creating an AAS receiving station and the digital twin for this. So this is actually a really small project, and I've been given a really small budget for it as well. But this is a receiving station at Rainhead, and my sort of task is to create a receiving station there. So what NAS receiving station is essentially, it receives signals from vessels, and it can tell the position of the vessel, what type of vessel it is, what cargo it's holding, and stuff like that. And because it's my systems engineering role, I have to look at it from the concept design all the way to its integration, and all the budgeting and legal requirements on what's the size of dish we can buy and stuff like that. And it's been a really great project because it's so small, you get to the nitty-gritty with stuff. So yeah, I've been doing that at the moment. Right now, we're in the purchasing side of things, so just trying to buy the receiver, the antenna, all the wiring and stuff like that, as well as talking to the software side and seeing how they're getting on with all the software which would be required to display the actual AAS data and actually get some important or useful information from it. And then talking to the digital twin team, because they want to create a digital twin of all the vessels going through the English Channel, so it can predict, in maybe 10 minutes time, this is how the position of the ships will look like, or what would it look like in 1 day's time, and how that varies over time. So it's been a really good project, just going through all of that. And outside of my project work, I also do a fair bit of extracurricular activities. And a good thing about a graduate scheme is you do get a lot of time off. I mean, I do work a lot at work, but you do get a lot of time off to do your own sorts of stuff. So through Thales itself, I'm doing an engineering management PG diploma, and that should be actually finishing in June, I think. So hopefully that goes really well. I've just got the interview to do, and hopefully that's finished off. In terms of sports, I do running and tennis. And in Thales, I attend career fairs as well as volunteering in schools. And as part of the IIT, I've become vice chair of the Young Professionals in London. And I think it's really important to do extracurricular activities and round yourself as a person as well as an engineer, as a lot of the skills you pick up from these aren't, the technical sort of skills that you need for engineering. It's more the soft skills such as presenting or talking to people, networking, which is actually really important, especially when you're just starting out and want to find out more job opportunities or a mentor or something like that. So what are the next steps for a person who just wants to get into engineering, or who's in sixth form or anything like that? While you're in sixth form in uni, take part in societies. They're a really great way to meet some new people. Even if it's not that related to engineering, it's good to know new people. You don't know where a new opportunity might arise. And yeah, it's always good to make that network. Apply to work experience, internships, or placements. It's so useful to have work experience or anything like that, even if it's for a few weeks, a week, a day, it doesn't matter. It's a really good insight into the way the industry or government or how any sort of engineering practice actually runs. And you can always use that to write about it when you're actually applying for a job. So it's really useful to have that sort of thing. Attending careers fairs is also a really important step. It's a good way to see opportunities that's happening, especially like meet the engineers. You learn about engineering from an actual engineer, and you gain that insight that wouldn't otherwise be available. Join the IIT as vice chair, you should join it, or any other institution that's applicable to you. But yeah, degree apprenticeships are also a really good way of getting a degree, or apprenticeships in general. People often overlook them, but they're really good, and you can learn a lot of on-the-job training, and it's a really good way to progress your career. The UK MOD as well as the UK Army have a really great engineering program, which I highly recommend if you're looking to go into the MOD sort of defense side of things. And also, it's okay to not know where you want to go. I mean, I really didn't. I tried basically everything, and I only found out in my third year of uni that I want to do engineering. So it's okay to not know immediately. When it comes to actually applying for jobs, start your applications early. applications do tend to fill up, and even though they say they don't, people seem to give a preference to people who are applying early. Tailor make your cover letters. Don't make a generic one. I've heard from a lot of friends who made a generic sort of cover letter. It doesn't really cover what they want to talk about or what the company stands for, and they get rejected because of that. And yeah, so you should definitely make a cover letter designed for that company if you're especially passionate about it. Another one is to apply for smaller companies as well as larger ones. The main sort of engineering companies tend to be like BAE Systems or Lockheed Martin or Thales or any of the other sort of car makers as well, such as Mercedes. And the problem with applying for that is the competition's a lot, but smaller companies also give a very valuable experience. You also get to work on smaller projects and you get to do a lot more. So don't discount smaller companies. You should definitely apply for as many people as you can or as many people as you're interested in. Use LinkedIn. I definitely didn't, but a lot of my friends who are within engineering found jobs through LinkedIn. They just messaged a person randomly asking, is there a job here? And they managed to get one. So it definitely works. Use the career services in uni. So I definitely did, but most unis have something where you can check your CV with them or ask your department, ask your tutor about engineering. Or if you're not in engineering like me, just go up to a lecturer and ask, what's your experience been? Because a lot of lecturers within university have worked in the industry at some point. And last but not least, perseverance is definitely key. I applied to 70 different places for engineering. Two got back to me. So it's definitely a good quality to have. And I'm not saying you will be rejected by most of them. I know a lot of people who've got accepted by all of the places they've applied to. So perseverance is definitely key, and seeing things through and, hoping for the best and not letting it get to you. And I think that's my final slide. So definitely message me on LinkedIn or send something to my INT volunteering account.
Thank you so much, Eeshaan. That was a lovely presentation. Really good to go through that journey that you've gone through and seeing some of the challenges that you've actually experienced. Particularly, thanks again for the tips at the end. We've actually gotten quite a number of really, really useful tips from our speakers here today on how to essentially get to where they've gotten as engineers, but also it seems how to get jobs. For example, as engineers who want to leave university, sometimes the anxiety can really set in. Getting the offers that you're hoping to get. Or you don't have the certain grades that you actually want or hope for, whatever the circumstances are. But then, we've got people who are here to actually show you that, with perseverance. And I've seen that that's a common theme with Shyam and Eeshaan, with perseverance, hard work, and also, being strategic in the way you do things, you will be able to achieve your goals. So thank you both very much for that. We've got a question here for both of you. And the question goes thus. What is a unique skill for system engineers in projects? So what is a unique skill that systems engineers provide in projects, essentially? So Shyam, if you could go first, and then Eeshaan go after.
Yeah, sure. I think one of the key skill that a system engineer should possess is probably decision making with excellent communication skill, because there would be several integrations, there would be several fields that you wanted to combine together, and when you sort of get to that point, making the right decisions right first time, probably in an environment that I work in, right first time is quite key. So that's something that I would say that you would require. But again, that's through experience that you gain decision making skills. But it's something that you can achieve throughout your career by having good communications in as I mentioned, making sure you have good communications and getting guided by a good mentor. So that's one skill that I would say is key.
All right, thanks. Eeshaan?
Yep, so I definitely agree with Shyam's saying. Sort of looking at the big picture of things and what you finally want as an end goal. There's a really good image that I saw, I think, in the last Meet the Engineers presentation, and it describes how systems engineers sort of have to decide how to compromise between different areas. So if a hardware engineer just wants to do what they want to do, then the system will look completely different to how it should be. And then if a software engineer could do all they wanted to do and look completely different. So a big part of it is knowing where the compromises are and sort of having the best combination of those compromises to produce the best product, essentially, or the best system.
All right. Thank you both. We've got another question for you. We've got a question for both of you, actually. So what is the biggest challenge you have met when working on projects in different industries? So what is the biggest challenges that you've met when working on projects in different industries? So Shyam, go first, and then Eeshaan afterwards.
Yeah, I think the biggest challenge is getting the buyouts from different industries. As Eeshaan mentioned, if you go with one single entity, the thing might look entirely different when you go to the other. So getting the buyouts, bringing that compromise is the biggest challenge that you would see as a system engineer. One of the instances where when a software engineer wants to actually provide some of the codes to automate something, but when it comes to mechanical, you can't actually implement that in real life due to safety reasons. So that sort of system engineer comes into play. And yes, there is a big deal of project management there as well. But when system engineer comes into play, he has the knowledge of both the technical and the project management side of things, where he would be more into say, okay, this is how you need to do it. Let's crack on with it. And yeah, no more fooling around. So that's one of the biggest challenges that I face even today when I deal with the different systems, different departments.
All right. Yeah, that makes a ton of sense, actually. Eeshaan, do you want to go?
Yeah, it's very similar to that. So I think the biggest challenges were during the MMCM, so the maritime mine sort of project. And the issue that happened with that was communication just across the board. So I had to sort of look at the technical debt, looking at all the different sort of departments, so electrical and software, and just trying to get them to actually compromise on what they were doing and just agree with each other and make sure, everything works together is always very difficult, especially when they've been working on this project for 5 years. So they think their way of working is the best, while it really isn't. And when someone's so set in their ways, as a systems engineer, it is quite difficult to sort of bring them out of that. I think another sort of thing is just negotiating with external partners, as they also have a very different way of working. So trying to figure out how they're sort of doing stuff, talking to their teams is also a challenge in itself. So yeah, basically 2 challenges, just communication and getting everyone on board on your changes.
Yeah, those answers really make sense. And I sense the theme here of, challenges that arise in project management, if you will. You both seem to really be involved in project management. You work primarily on specific projects.
Yeah.
And it seems that you have to manage, say, communication, stakeholder engagement, and buy-in from different people on those projects. So for anyone that is not just in systems engineering, in general engineering, project management, if you will, you do have quite a bit to learn from our speakers. Last question is to both of you is, did you choose systems engineering specifically, or did you drift into it over time? So if you could just give 1-minute answers.
Yeah, I must be honest, I didn't choose system engineering, but I think I was part of as a product development engineer. If you had seen my slides, After product development engineer, I swiftly got into resident engineer. So I got the sort of experience in both project management and technical knowledge. When combined together, I knew, okay, system engineering, something that I need to do. And that's how I drifted onto system engineering, which I think it's fair in that 7 years sort of growth that I had.
All right. Eeshaan?
Yeah, I feel like most systems engineers I've spoken to haven't started off as a systems engineer, they've drifted into it. And it's basically the same with me. I sort of joined as, research engineering. I really wanted to go into research and I just drifted into systems engineering. And I think a lot of it's down to, I like learning a lot about the system and being part of the entire process, as well as, making sure it's going the right direction and being involved in that side of things. So yeah, it's something I drifted into, definitely not sort of sought out.
Okay.
Yeah,
All
someone said, I think seeing the big picture. I think that's what system engineers do, and that's what system engineers should do. You should see the big picture. And I agree with you, Eeshaan. I love seeing the big picture.
All right. Thank you both so much. Thanks for those answers. Thanks for the presentations. I have learned a ton, and I know a lot of our listeners have learned as well. Please, to everyone, do contact us for more information on how you can join the IET London Young Professionals Network. We're always looking for people to join in and help out. Follow us on social media, on LinkedIn, Twitter, Facebook, Instagram. And as previously mentioned, there will be more of these, so please stay tuned. Have a wonderful evening, everyone. Thank you all so much.
Thanks all. Thanks, Toby. Thanks, Eeshaan.
Thank you for having
Bye
us.
all.